Thank you very much. Short introduction. My name is Zhe Shu. I'm the group leader at the Schickard Institute. Schickard is like Fraunhofer, if you're familiar with that. So we are based on the Baden-Württemberg. We are doing applied research, focused on the industrial transfer, so technology transfer, developing a new technology, bring to the industrial. My talk today is about multi-material additive manufacturing of 3D electronics. Let's see if that works. Okay. I will start with a short introduction about multi-material additive manufacturing of 3D electronics, then followed about a short overview, very quick overview about current technologies in this field. Then I will shift to the unique approach where we are doing at Schickard through molten metal printing to achieve this 3D electronics printing with multi-material, followed by workflow, how we actually doing that layer by layer. Afterwards, some small characterization to show that how reliable it could be for 3D electronics application. In the end, I focus a little bit short application examples to give you some impression what it can be done. Then ended by a summary. I start with why we are doing this printed and 3D electronics. Basically, this all starts from the traditional PCB manufacturing. As you can see that for all the electronics, it seems very simple and produce very measure, but it need a lot of process to really make the PCBs. And at the moment, the high challenge is also the environmental because it's really an aging process. It's use a lot of chemicals, a lot of energies, and use a lot of resources. So that's why people are really think about why not just print the materials so we can save the resources and so on. So that's why there's, of course, it's just some industrial revolution, and currently the 3D printing is really going up, and people are thinking, why not? We can just doing very simple process. We're just doing the 2 steps, making like just print the dielectric, the polymers, and then also print the conductive traces. Then we can have a PCB electronics. We can even have the 3D because now we can print the 3D electronics. We don't rely on the 2D PCB board. So that's the whole concept why we are thinking about, and people are really doing to push the technology to make it really environmental friendly and also make local production possible. And there are a lot of trials to start with. People are thinking about, okay, let's try it. So basically the first start was like just use standard 3D printing based on FDM or FFF technology, print the polymers. Then they just use some server paste to try to print the paste, and then use different machines trying to do that. Of course, it somehow works, but really unreliable and the process very complicated. There's also other approach. For example, use SLA 3D printing, make a lot of channels, and then they just fill the channels with liquid metal. So then you have really fluided metal inside. You can have an embedded 3D circuit, but since the fluid metal is not really highly conductive and also a bit toxic, it's not easy to really into the application. Then there are other trials that they combine different processes. For example, you do standard 3D printing, you take CNC machine to really make channels, then you use standard paste printing, dispensing to print the server inks. Afterwards, you make solder paste, then you do the reflow. It somehow works, but it's really complicated with different processes, and you have to readapt to different machines. The latest, or at least the most commercialized way people are doing is from the nano dimension. So that's the company very successful in the market. They promise that you can do the PCB printing like within 24 hours. So basically, of course, the machine itself is really expensive, like 1 million euros for one machine. And what they are doing, basically, they take the standard inkjet printing. So you can do the inkjet printing for functional materials. They print the dielectric, and then they also print the silver ink. And they do